Hey guys, so as you can see by the title, we're hooking into a tray build, and basically it's going to be fully formed out of aluminium and all TIG welded up. So behind us you can see the N60 build, and we've been working on this for some time now. There's been a lot of intricate design and stuff going on with it, pretty much stripped all the original stuff off it. It once did have a life of a rear coilover setup, but we've since gone through, decked it all down, cleaned the chassis up, braced it, put in a new towers and everything like that, and then also started to form out everything else. So you can see most of the design work that's gone into this is very modular and trying to pretty much permit heaps of space for everything to work in situ of itself. So put it in context, it's basically our geometry, how everything's moving, our weight ratios and stuff like that, leverage points and stuff. We did have a massive tank in this prior, and it's about 120 litres, and the issue that we did have with that was obviously it's a lot of fuel as a leverage point on the rear. Coilovers do not like being changed dramatically in one end of the weight scale to the other, so that's a hard thing to start biasing towards your weight. Most of the time, if you've got coils front and rear like this, you really want to put most of your weight in the middle point and push out from that. You don't want to have this massive leverage unless you're pushing down to like trophy trucks and pre-runners and stuff. So basically, we had to form up a new tank. I've done that with a new belly plate, bash plate into that. The tank sits at 85 litres capacity now, and the design is very good for a departure angle. So as you lead off rocks or go up something very steep, it basically takes away the possibility of trying to skim your tank. So we have like a nice run off on our departure angle or our exit point. Now, moving on from that, we've gone through and put our tray mounts on. These were fully TIG welded up. There's a fair amount of effort that went into these. It's not something you really need to do, but I'm trying to be quite meticulous on this build, and I want it to be a bit of a staple. I want it to, you look at it and you go, pretty much everything on that is near perfect, you know? Not trying to push wind up myself, but it's basically, I put the time and effort in to not have anything loose ends sitting there and go, I didn't like that, that doesn't work well. And the biggest thing I can't emphasize enough is fitment. And I've learned this over the years a lot, is rushing, putting that time, you know, in the right places and stuff, and you're here trying to force things on, they don't work, they elongate holes. Far from that these days. And most of the things I pride myself on now is being quite precise with things. And that does come with a lot of time. Especially with building this, this has taken a fair amount of time because everything is trying to be quite, you know, perpendicular, parallel, and everything is even and symmetrical that flows throughout it and everything like that. And to a lot of people, they might think that's quite an easy thing, and you might see there's people on social media that bang this stuff out on weekends, but go look up close to their car, and I tell you right now, there'd be a million things you could pick on it. I want this to be something that people can look at, and they go, the workmanship's been done, and I'd be happy to have that as my own car. And that's how I treat customers' cars. That is why there's so much effort gone into this. Now, as we move on, we're looking at building an alloy tray. Now, I'll put some vulnerability here. I can weld aluminium fine, all that kind of stuff. I've never made an aluminium tray. The reason being is because most of the time, we've always used steel trays and stuff like that. They're good to take a hit, easy, they're cheap. Easy to weld up and stuff, especially in the backyard. With aluminium, there's a lot of things that have come through now, like spool guns and MIGs and all that kind of stuff, but a lot of the time it's a very expensive exercise to weld up, and especially the skill set takes a lot to get there too. You might be able to sit down on a bench and weld up coupons, which is like little test pieces, but can you weld up a whole tray? That's a different story. I'm not saying no one can do it, it's a practice thing, and it takes time. So, reason why I've stemmed for the aluminium tray, and that's why we're going to go through this on the build, is basically to alleviate a bit of weight. Also, I want to put a fair amount of design into this, which I can sculpt a lot better with aluminium. It's a lot more malleable in material, and the radiuses that you can get from the finished edges just are a bit more bigger, and they flow a bit nicer. Also to, like I said, it's basically around the weight. Hiluxes don't have a great GVM. We already do have a lot of unsprung weight throughout this vehicle, especially through the center of gravity of this car. We've still got an abundance of weight too from the actual metal structures that we've put through this. We've got a double transmission in it. We've got brackets holding that up. List goes on. It all adds up. So the more we can alleviate that kind of weight, the better. And there might be 50 kilos, it might be 100. In the scheme of things, it all adds up, and that will help towards the end goal. So that's one thing. Now, the misconception about aluminium and steel trays is basically a lot of people will always go around to the strength. Yes, the yield strength of steel is a lot higher than aluminium. And I guess depending on how you make the structure and stuff like that, and how your torsional strength goes through your chassis and stuff, if your welds are not correct or how you've braced it and stuff like that, you will start stressing that aluminium tray as you basically torque it up and induce cracks into it. So I'm going to show you my idea and how we go about it, and we'll start cutting up stuff and working out basically where we want to start with our runners. We're going to work out our rails now, and pretty much all we need to do is work out our material height, which is 125 mil, and then where we sort of want to sit with our tray height, and that will dictate the gapping for that we do for the straps on the bottom section to tie in our mounts. So we don't want to go higher than this tire. Pretty much going to go to this height here, and then we'll cap the top of this with a nice shielding kind of section. So we've got about 200 there, which would give us a 75 mil high bracket, which we're looking at about that. So you pretty much want to look at that in terms of like, okay, how easy is it to get my fingers in there? Can I get a bolt in to here, drop it down? So I'm going to call it 90. And we can dictate that up here a little bit more because that tire has to come up a little bit more on the front section. So I'm going to call that 90 mil high on our strap section underneath, and then we'll do our 125 mil runners along that. So we'll pretty much bend up our little straps underneath, which is 6 mil flat, and then we'll side cap it with 4 mil, and I'll show you how and reason for doing that. It's basically just to strengthen it up because our stress is now pushed onto the bracket because I'm going to bend them at a bit of an angle. Now, if they were dead straight on a 90, it's a vertical strength through that and it's pushing towards it, down on it. Once we open that up, you start to want to push on the outside of that weld and then crack it. So we'll cap it in and do a nice little sheet on that just to pretty much tie them in and strengthen them up. And then we'll do a little profile cutout so we can put our bolts in there and drop them down. I've set up the rails and the bandsaw now. We've got them ready at about 1400 mil in length. This particular bit of equipment, these are awesome bandsaws. They're pretty much normally a assisted kind of setup, which basically you just turn them on and they start feeding themselves. Awesome for continuous and having a very good efficiency with doing mass production with things. But by all means, you don't need this particular setup. Another good thing for RHS and stuff is to use like a drop saw, which is one I've got down there, a Bosch one. That's actually a coal saw, which is a metal blade. Good for aluminium because the abrasive discs clog up a lot. Other than that, you can use a jigsaw, circ saw, stuff like that. They're also great for it. A lot of the stuff I use is generally the Milwaukee, so the Milwaukee jigsaw, Milwaukee circ saw, stuff like that. Anything with pretty much metal blade is fantastic on the aluminium, especially the new bits in them, like a new blade. The contaminant, and when they cut, it's a lot easier to weld quickly without having too much contaminants in there. When you use abrasive disc and stuff like that, they generally clog up the aluminium and they impregnate it. And when you weld it, the cleaning cycle and stuff is a lot worse, and you'll see that discoloration through the arc as you weld will be a lot more green. So that's just one thing to consider, especially when the TIG welding process has to be pretty clean. So we'll set this up, get it going. Awesome bit of thing, chuck the water on. And we just set it down. And that will pretty much start auto feeding for us. So while that's cutting, our next step. We've got some aluminium flat bar here and it's 6 mil. We are going to put a 60-degree bend in this. So we're looking at an 80 mil gap in the middle. And then we'll have wings at 110 long, which gives us a height of 90 mil set at 60-degree angle. We'll have a 12.5 mil hole in the middle of that. You can see on the bench here, we've started setting up our drawing. I like drawing on the bench a lot. Worked out our angle, 60 degree, 110. That gives us enough material to knock off the top edge and create a flat surface along that parallel to the bottom. But you don't want to be welding with having a little bit touching and then we've got this big gap. So we'll get that married down there and then we can stitch it on nice. So that will account for that. And these will be bent up to give that kind of cool look. And then we'll do a nice capping of 4 mil on the outside and fully weld that in with a internal one there to fish plate that towards the thing. Seems like a lot, but like I said, this tray is going to be pretty fancy and there's going to be a fair amount in it. As I was talking about before with this tray, we've set up the hole centers and everything like that. And to tell you how precise I have gone with this, with lasering and working it all out and everything, in its parallel plane at the moment across from hole centers to hole centers on the other side of the rails, these here are all within the exact mil. So now we can make 2 rails identical to each other and we don't even have to worry about fitment or anything like that because they'll just pop straight on and have no issue. That's just one thing that I want to highlight, is doing that nice precision there makes the next part of this now really easy for myself because it's just mirroring the object again instead of making a separate side that's wrong to itself, if that makes sense. So pretty much we'll get these all knocked up and cut out and then we'll go over to the bender. I'll show you kind of bending them up and then we'll start getting ready to TIG them out. So I've gone through and hand filed everything. I like to do this because it stops that impregnation of the consumables getting in there from the disc and stuff like that, and it's a nice cleaner weld. Pretty much now we've got our bottom straps. So we've got the 2 rears which are going to be the same, and then the front I've added a 125 mil extra because we're going to roll that in and actually cap the front of it and TIG weld that in so it's a bit nicer to look at. Pretty much all we're doing now, getting our centers, which will have our 80 mil surface area before we do our 110 folds at 60 degrees. So we just pretty much go through and mark them up now. And like I was emphasizing before, take the time to individually measure things and stuff like that. Like I used to really be bad at just laying things over the top of it and that. And by the end of it, you actually go and look at what you're doing and you've put in a massive variance most of the time. Another thing with consideration is obviously like texture thickness too. Sometimes you might have 1 mil on a fine and then you might chuck in a big Sharpie and you've started to throw in a variance of 2 to 3 mil by the time it actually draws a line. And I know this might sound like small little petty things, but it all adds up. It's just all these things you got to consider. And there's things that I've come to learn that it all affects. So with these ones that we've got here, these are the ones that we're going to chuck in our extra. So I'll mark our centers on these. And then our back strap, which will tie into the capping of our rails, which should look pretty nice actually. There's something I was thinking about while I was picking up from the steel shop. I thought I may as well do this one a little bit different. So I'll work out all these and then we'll shoot over to the drill press and knock them out. So we've got 50 mil strap here. Another little thing too is that even when you do set this at 25 and accounting for the texture thickness, I normally go around that 24, just because by the time you actually do the center and cross-reference it to the other side, you can see it's bang on because we've accounted for the thickness of that texture that we're talking about. Whereas if you put that at 25 thinking it's doing a precision measurement, you will not get that hole center. It will most likely be offset. So another thing too is with the aluminium, even though it's very easy to drill, it does like to wander with the drill bits and stuff when you start them off, especially if they're not super sharp and you're running a pilot. A pilot meaning a small little drill bit to basically start your hole off instead of just trying to put a 12.5 straight through this. A decent hole punch, or hole center punch, sorry, and set that up. Most of the time you'll find these have got magnetism on the end of them and they've got shavings on and all that shit. I always clean them because you'll try and find your center and you're fighting with those shavings putting you in a different spot. So I'll finish marking these up and we'll shoot over to the drill press and start drilling them out. So when it comes to the drill press, these can be a very precarious creature sometimes because they do have a mind on their own. The belts will spin, the drill bit will pick up stuff, pull it out of the vise, we'll throw it around the shop. I'll tell you, when I was younger, drill press and me did not get on. I was always a little bit worried about them because I had more accidents with them than I actually had success. And that's because I'd always just try and hold stuff in there and not really set it up properly, or didn't understand the speed between the belts and stuff. Obviously the alloy, you don't want to be super crazy speed. Also too, another thing when it comes to the actual cutting compound that you use to get through this, you want to use something that's sort of more waxy and stuff like that. And a good one that I used to always use, especially when I was on sites and stuff, is you're always there having barbecues. Go to the grease trap underneath the barbie, and that grease, awesome for cutting. Especially like hole saws and stuff like that, it really stops it from sticking. And it's a cost-effective thing at home. You've always got your barbecue and you probably had cook-ups. And most of the time, you're gonna have a nice big pot of grease underneath there for free. Other than that, you can get specific compounds for alloys, and they do very well. A lot of the ones that you get like Treflex and all that stuff doesn't really work too great. But by all means, you can definitely just do this at home with a drill. So we'll set this up, shoot it through with a nice 12 mil. And then once we're happy with that, we'll go through and chamfer off the edges and clean them up. And then we'll head over to the press and start bending these up. And I'll show you the little tool attachment I've got. Super cheap, but God, it does a good job. So we're over at the press now. I'm about to do our final bends on these at 60 degrees. This attachment that I was talking about is very cheap. They're only about $210. They do go up a bit dearer depending on the brand, like Hares and Forbes and stuff like that. But most of the time they're good for about 6 mil mild steel. A lot of things that come into the situation with bending is basically like your V blocks, your bending radius, the actual radius of the knife gate and stuff like that. The metal of which this tool steel might be made out of and stuff. There is a lot that comes into bending and what it can actually permit before you do overload it and break it. That's something I don't know heaps about, but I know enough to keep me out of trouble. Now this is going to be well adequate for doing 6 mil alloy. One thing to take in consideration with this is we don't want to overbend it, because as we go to bend it back to its other shape, you start to stress it as you manipulate it from both sides, and you will create the fatigue in there and it will become brittle and snap. We don't want to do that. We pretty much want to bend it up to the point of where we're happy, and then don't go any further. So instead of using an incrementometer and stuff and working out the angles and everything like that, I will basically just eye it, because I've done this a fair amount on here now, and then I'll just use this set square here, which has been set at an angle for what we need of 60 degrees, and we'll just pretty much start eyeballing it and go from there. So with these, pretty easy to set up. I've got a nice little light in the background here to get a shadow on here to see the line. Some dearer setups will have like lasers and stuff, or they'll have like a light that shines across. We don't really need that, but I pretty much push it up a little bit and you get it near the texture mark, go down a bit. And now before we go any further, we'll quickly just chuck a square on it, because we don't want to start bending these too off. And that should be nice there. Righto, so we'll have a quick gaze at that. And you can see we're not too far off, probably about 10 degrees there or something. So we'll just inch it a little bit more. There's definitely better ways of doing this, especially CNC if you've got that. You don't want to go too much. You don't want to go too much, otherwise, like I said, you'll go over. And look at that. Bang on, perfect. So pretty happy with that. And like I said, this is just a thing of doing it so regularly, you start to adapt to the things you use, and not everything has to be precisioned, aligned with equipment and stuff like that. A lot of the time, you can get to a point of actually eyeballing stuff. So yeah, we'll do the other side, and then we'll pretty much get these set up on the table at even spacing. Like I said, both sides are symmetrical and even in their hole centers, so all we have to do is make one side, mark it all out, and we'll pretty much put a nice plan across the desk, and then get everything F-clamped in, and we'll start going through and TIG welding. I've got it all set up on the bench now, and basically I've gone through and worked out my hole centers. So you can see I've got a nice piece of RHS here that I've laid on the table and clamped in. Pretty well, all I've done is gone through and mark out our hole centers. One thing with the tape measure and stuff like that, I always run off the 100. I don't like running off the actual end of the catch on it, just purely for measuring out and stuff like that. And also taking consideration that 100 you do put on, you got to take off. That can stuff you over too, so I always do double check. But it's a good rule when it comes to trying to mark out hole centers a lot better instead of running that catch on it. Now, gone through, done that. I've pressed this side here because these clamps are pretty even spaced next to each other. Due to the one being up the back here as a back strap, when you go to clamp that, it's going to want to teeter it in, which will then push this up. So we'll start here and get this as a good base, and then we can move our clamp up here and do that again. So pretty well, we'll go set up the TIG now. I'll give you a little bit of explanation around the TIG, some functions of it, setup, and sort of the reason why we are using the TIG in this process. And yeah, pretty much tack it all up. We'll shoot it in and see how the hole centers go, and we'll start building the tray from that as we have our new rails to put in. So when I get set up for doing the TIGging, with this 8-meter lead that we've got, I like to just pull like 1.5 meters, pinch it, and then chuck that over my head. I do that because then I know I'm dragging X amount around. It's not going to pull on me if I do move or radically do something. My body will pull this around. My body's got more force to pull that than my hand's going to counteract that on the weld. So we're all good there. Like I said, fitment, how it all feels, stuff like that as we weld. It's like a pencil, how I hold it. And then we've got our rod. Check that your gas is on all the time so you don't have to chase out porosity if you fuck up. And pretty well, we'll go through here and start tucking these in. So you want to pretty much sit with alloy, and as you kick it in, you want to watch for it because it will start to get pretty much start to ball up, and as the green starts to dissipate, you'll see a nice shiny film come over. As it shields, or as it comes through, and once that shiny little pool starts to come through, you'll see these little craters start sometimes. We want to push a little bit longer in it so that the craters don't actually sit underneath there and create a shitty weld. Now the other thing too with this is that start to learn, once you get confident, how to weld in awkward positions and stuff. Not everything is going to be easy to weld all the time, and the more you learn how to be in an awkward position, the better it is, because you won't always have to put everything in a certain way. The reason why I say that is, like, let's just say most people have to take things off and weld them flat on a bench. Whereas sometimes, you know, like your vertical welding underneath or on a chassis or something like that, the beauty of it is that you don't have to keep taking things off all the time. And it's just constantly learning how to do that is a good practice. You'll get a lot of people say, oh, I can't weld that because it's upside down or something like that. So we're sitting there now with that one. It's looking pretty good. Sweet. Actually, you might go up a little bit on that just to get that nice and square. Now we'll shoot this one in. Sometimes it can be awkward picking these rods up too. Now you'll notice I'm keeping my torch there for a little bit, and that's just to sort of keep that gas post flow on the tungsten so that it doesn't stuff up. A lot of people like to finish welds and take it straight away. That's where you stuff up your tungsten, especially with your filler rod. The filler rod's not too bad on alloy, but when you got your stainless, you want to keep it in that atmosphere. You don't want to be taking it out because then you make this get oxidizations on it and stuff, and you'll pretty much impregnate your weld next time you do that. So when you're welding, you basically want to be like dab out, dab out, dab out, but we're still in that plume. We don't want to be like this, because that there, you'll start putting porosity and shit in there and oxidizations and that. Now the other thing with alloy is when you go to finish off your weld, we generally need to feed a little bit more into it so that we don't get a crater. So on our corners and stuff like that, we pretty much want to feed a little bit rod in as we taper off. So I'm on T2 at the moment, so it's on, keeps going as I hold. As soon as I let go, it takes off. 4T is latching, is pretty much you click it, stays on, click off. When we get to the end of alloys and stuff, you generally feed a little bit more in as you click off, and then you keep swirling it. And there's a point of that alloy becoming not pulled up anymore to feed in. It's sort of hard one to explain, but let's just say if I was welding, got to the end of it, I would pretty much sit there and feed a heap in and then taper off. And then as I know it's starting to get not sort of sticky anymore, I'll pull it out and just sit there swirling it a little bit. It's a very quick motion. It sounds like I'm making it like 10 seconds there, but yeah, as you do it, you just want to taper off and swirl it around as you're feeding in. And that'll give you that nice little cap on the end where it's pulled up into a nice ball and ties in your angles on your different like directions that you go on your stuff. So that's that side there now. We've tacked a little bit. I'll take it over and we'll check our fitment. And if we're all good there, we'll tack the other side up and we'll look at pretty much doing these splice plates now. Check out how this fits now. Get that on there like that. We'll chuck a bolt in here. Chuck a bolt in there. And see, that's what happens when you actually spend the time to just make everything nice and perpendicular, straight, measured out, do all the tiny little things. I don't have to fiddle around with this now. It's just the next thing we keep moving on with. And that's where, like I said, it takes years to get to that point of just being that little bit longer in your steps because it pays off. So we'll do the splice plates now and we'll do a little video on that with the computer on how we pretty much set up a DXF cut file, and this would be great for you guys because most people locally will have a CNC plasma or laser person, and a lot of those places are happy to take your DXFs and cut them up for you. So while you're at work, you can get all this stuff cut up before the weekend and have nice stuff to weld when you get there. Especially you can be more intricate with your designs and bending and stuff like that instead of making these straight alloy trays. You can chuck so much more nice things into them. And especially with the alloy, we can start putting profile bends in to bring that structural integrity through it, because now we've got more bends in there and that kind of stuff, which is taking away from that, you know, flat surfaces from bending. So chuck that over there and we will do the splice plates now. I've just started knocking up the splice plates now, and this is basically the design we're looking at. So this program I'm using here is called Fusion. Fusion 360 is extremely user-friendly. The help that comes with it if you do get the paid version. Paid version's probably about $100 a month these days, depending on how far you want to push the program about extensions. Pretty much everything I do is covered within that, and that even comes down to the aluminium products that I make and stuff like that too. You can get student license, and the free stuff you can get off the internet too is still pretty good. What I've gone and done here now is made a 2D drawing, which is, I'm not going to go into it too much because this is very user friendly. It's so many tools up here, and once you create a file, it's after that is the things that you sort of need to know. So we've done this and finished it. I'm happy with the sketch. Now you'll notice that when I put my mouse over it, it highlights as a fully closed object. If it doesn't do that, there's probably because you've got some small little piece in here that's not connected, or you've done something that the algorithm's not happy with. If it doesn't do that, when you do a DXF file, the DXF will not like it because its cut path will have something in there which is miscellaneous and doesn't like it. So let's just say we did this radius and we had a little piece of straight edge coming out here, it won't like it in the G code. So I've learned that from mistakes because you send it to people and they're like, hey, it's not closed up, it's not working, it's not this. That's why now I proof check everything and make sure it's all good. So that's our design there. Generally what I do to verify that is I will extrude it. Now extruding is taking from a 2D plane into a three-dimensional kind of landscape or look. I'll just chuck 2 mil on that, and now that is our object in a 3D form like that. So 2 mil fixed sheet, and that's what it'll look like. In terms of our design that we've gone with here, it's basically going to be the capping on our aluminium externals there. And this section down here is going to be for the bolt provision so that the bolt can go in. That there is 20 mil high to give provision for a spanner so that we can do it up and still get access to it. This here is a slot that I've put in from a center point, and that will be filled up with aluminium to basically bond that splice plate on that surface area there, because if we just weld around here and here and here and here, that is still unbonded in the metal there, so that will hold that in. Very similar to what you do on car, splice plates and kind of chassis bracing and that. So now that we've done that, we go from design and we go to a manufacture. In the manufacturing, this is where we can do heaps of cool stuff, especially around CNC milling and that, fifth axis, everything. I play around a lot in this because I like to see what my product's going to do when I give it to someone to make sure that it's going to be workable, especially around the fifth axis. I like to see that we're not going to drive the tool into it and not work and stuff like that. So now we'll go to basically create a setup. Most of this stuff is prompted to you on how to use it. Go to setup, and this is sort of what we're looking at. This is our physical space of what it's got once we put this external to our cutting machine. So now we'll go on here. I pretty much just go on here and pull it down to no additional stock, which that is called stock. We reduce that down because we don't need it. And then we pick our point of which we want to have our machine as a center point. So say if you've got a CNC cutter, which not everyone's going to have at home, I understand that. They are getting a little bit more user-friendly in terms of pricing and stuff. But if you were to send this to someone, it's basically the start point of where your X and Y is going to be for your cutter head to start going from. Once we go to zero it out on the actual deck. So, because my deck's not massive on my one, I get a lot of external cutting done. The one I use in the shop, which is the plasma, it will cut up to about 12 mil with a very small kerf. Kerf is the angle of which it comes down as it pierces through. We want minimal kerf so that our plate is pretty true all the way around. Aluminium on a plasma is not fantastic. I will have to do a bit of cleaning on it because it will impregnate itself a little bit like that, but it's not too bad. I can chase that out. Laser is a hell of a lot better, but I'm not going to get this laser because it's the turnaround time for me. I can clean this up. I could even jigsaw it out too if I really wanted to. So here now we'll select this so it's easy for me. So when I went and got the plates all cut up, I got them gilloed at X amount of material by length because I knew I'll just keep going bang, cut, move it along, bang, cut, and that's what this reference point's going to be for that zeroing each time, which I'll show you on the machine once we get there. So that's us there, and that's created our setup file now. So cutting, We go to tools. Now the tool library on this has heaps of expensive plasmas and all that kind of stuff. My plasma's on there and that, but I don't bother doing it on here because I like to change the settings on there. What I'm talking about here is basically the settings on your plasma can be put into here in your G-code and stuff, so that when you send it to the plasma, you don't have to worry about changing all the settings. I'll quickly touch on all the settings when we get over there, but that basically is something I do over there. So we'll go down to here, random plasma cutter. That's all it needs to know that it is doing plasma. Now we go to geometry. Geometry is going to select our object, so it's created that as an object, and that's why we extruded that to verify that it's a closed circuit. Now we'll go to here. I just click smoothing just to give it a little bit more nicer tracing and stuff as it goes around on the radiuses. And then here is a couple of little things. So if we were doing this little slot here, which is going to be a 5mm width, this lead in here, we've got a 60-degree lead in, which means it's going to go like that, go around, come around, and go back out. The reason why we do that is because we can reduce how much area we need to cut in, and the more we can stabilize the plasma before it goes into the actual cut we need, the better the finish is, instead of having these weird holes and stuff like that. So 5mm might work. We'll notice once we go to post-process this to see if it's all good. It might be a bit too long for inside of this section. We probably might just change it down to a 4 now to account for that. So 4, and then now we'll go here to our middle point, because that's where we want to lead in, lead out, instead of going in on a radius. That's that point, and then now we've only got the external. So the external we'll just chuck somewhere out here, say like that. Once we go through now, it will generate. Now if you click generate and that didn't pop up there like that, that would be because it can't physically do it in the algorithm. So go back into your file and make sure that you reduce that down. So right there, it's not great, but I'll get filled up with weld anyway, so I'm not too worried about the pierce on that. It is what it is because it is such a small little slot. I don't want it massive to chase with a weld. So you can see now we've done that, and all our cuts, so that's an internal cut, and that one there is an external cut. So will be our external surface area of what we've created instead of doing the in cut. If we did internal, we might reduce the overall of this down by like 0.9 scale, and it might take about 1 to 2 mil off the actual overall of this. So now that we've done that, we can actually simulate this to make sure that it's going to work on our machine. We click play, it's the cut, and looks pretty good to me. Exit simulation. Now we chuck on to G-code. G-code is the post-processing of which the plasma needs to read to basically work out all of the points of trajectory as it moves around on its X and Y. Mine's a bit different. My particular setup is actually a single arm CNC, so it uses another algorithm on top of it to basically compensate for not having a X and Y linear movement between itself. It pretty much creates that radius movement through its arm to account for that. Not as accurate as in a standalone X and Y one, but it's actually pretty damn good, and the size of it's amazing too. So we'll just take this as alloy splice plate. Splice plate. That's going to go straight to my thumb drive. The thumb drive's got all of my G codes on there. You don't really want anything else on there like photos and bloody songs off Nickelback or anything like that. We want to keep it pretty much clear towards that. So now this will create the cut for what we need, and we do that. It will post-process, and that's good to go. Let's kick it back a little bit. Go back to our design. Now if we're on here and we've got our sketches, we can go over to the sketch that we made here, and we can go export, save as a DXF. When we save that as a DXF, that is what we can actually send to a laser cutter to get cut up. Two things, or one thing here. When you export this, the reason why I went sketch and save as DXF, opposed to doing it outside of this, is because when you do this, it stays true to scale on millimeters of what you do. I don't know why this does it, and I'm sure it's something in the settings and that. I've asked Fusion, and I don't reckon they know either. But basically, when you export and you pick as a DXF file in here, it changes the scale of it. And I don't know why, but that's just how I've always done it, is I click over here and do that. So now that we've done that, we do need 4 of these, which we'll cut out, and then we do need 2, which have a straight 90 up. So I'll modify this file now, and we'll get that all set up on the plasma and show you how that cuts out. we've gone through and finished our supporting rails for the base of the tray now. So they are sitting nice, they're all locked in currently and have a separation parallel to each other the whole way down the rail, which now provides us that good base to pretty much start building our floor from. So you're probably looking at this and thinking, okay, this is quite high compared to what you would make on your side. You got to understand this car is in a custom state and pretty much things have to adapt around it. The tray is not going to be humongously high off the ground, like I mentioned in the start of the video, but it has to accommodate everything we've got going on here. So take that in consideration when you're making yours. You don't really want to make your tray bed too high off the floor, but we do need to take in consideration how much steer access we actually do have in this, or roll center, as this rotates around on compression and hits bump, that is going to come up and tuck in a little bit. So that is the reason for the actual tray design, as you can see, and it's going to permit really nice because it alleviates the chance of the tire touching in on our tray bed now. So as for our height, that is not where it's going to sit. That is purely just sitting there currently as a square for us. And I'll show you where we're at. So I've pulled the tire back a little bit, and the reason for this is that we are going to put a strapping in here. So as you can see, with all the stuff we've got going on in here, it's quite hard to build our traditional slats that go across. So you might maybe shoot probably about 8 slats through this and shoot them out to the sides, and that's very easy. You just cut them on, your saw in and drop them all in, weld them all in, happy days. With my setup, I have to do a lot of mitering and certain angles to put strength through this, but still keep the height down. Now, what I've done is I've pulled this tire back, and in this little section here, I've worked out that we have about 320 mil from center point, so 160 either side, and that will kick us into a 30-degree angle. So as we go into this 30-degree angle, which will offset us through here, we'll kick back at 360 mil into a 400 mil dog leg. So as that leg comes out, there's a little bit green on it until we work out how much we actually want protruding out of this headboard. We don't want it to be like a farm spec one way out, but we'll keep it probably 50-50 of this actual car's overall design. So this was purely just a straight edge at the moment, and I've gone through and made all my measurements, and I've started to work on the actual beam. So our beam here at 30 degrees that we want, pretty much easy thing for you guys is you can work this out in millimeters too if you want. It sits probably about around 12.5 mils either side of center line. On a 50 mil box will get you about 30 degrees, but even with a angle square like this, a combination kit that you normally get, a lot of these engineering ones you get these days come with 3 different attachments. So you might have a pipe center, you will have a angle finder, and then you will also have a just a normal square like our square over here. Another handy one is this here, which is a digital angle finder. I use this a lot on pipe work, and it's fantastic. They do chew a lot of batteries and they don't generally turn off and they get a bit weird, but most projects I'll sort of buy a new one here and there because they do get pretty shitty. I've looked down the path of getting an expensive one, but they don't really get much better. So if someone's ever seen a better one, shoot me down in the comments there. So you can see here, we've done our first cut. Where are we? And that is sitting at 50 degrees back off the 90 mark on the top section of this. And you can see there we are beautiful. So we chuck our 30 degree that we got on here. Hopefully it hasn't moved. And we're good on that too. So this is our 400 runner that I'm talking about, which will stick out the side of the tray. This will go into the 360, kick back on another 30 degrees, and then that will give us our 320, and then we'll mirror that both sides, and we'll pretty much, this is the next part, is that once this is all tacked up and welded, pretty much about 75% of this section will be mitered out so that it can actually drop over the runners. Now, I love making my life hard, that's for sure, but the reason for this is because I wanted these to be up higher, but I want the tray bed to come down and the supports to be there. So as we bring this down 75% of that box section, we will come along here, and that gives us just enough tuck for a 37 inch on full bump on this 5 inches of up travel rear. and then that will pretty much marry in and give us a bit of strength there too, because we'll have that section on top there, and then it'll be stitched down the sides too. So it'll be very strong in the end of it. It's just very finicky. But that's the design I want to do, because I don't really want to weld stringers off this. I want to try and put a nice design in it. So as we go around here, kick back, then we'll do one in front, which will kick along the front section, and then we'll probably tie it in the middle here, a cross brace. As for the back, we don't have to have super supports on this tray, because it's not really structurally doing too much. It's more for aesthetics and probably carrying a fridge, in all honesty. There's not going to be tons of weight, and if we did have a canopy, it's going to be up on the front section where all that bracing is. The rear will still get braced, but it's going to have a bit of a different design. I'm playing around with ideas at the moment with the headboard, and you can source different kind of aluminium radius edges. So this is a pretty standard edge on this RHS here, but a lot of, I think it might be like Urich aluminium or something like that. They do different kind of extrusions, and they pretty much have a bigger radius on there. So if you're doing a headboard, look out for that, because a nice big radius is going to look a hell of a lot nicer on your headboard than a sharp edge like this. As for the rear end of this and the front of the headboard, I'm just sort of weighing it up now, but I'm probably going to do it all out of individual pieces of bent sheet. It's going to take a lot of effort, but I think it will pay off. And the reason why I say this is because I can make a nice three-dimensional headboard and introduce shape all through it, much the same as the rear of this. I will do it in segregated pieces too. So the headboard will be one piece, as it's all fully welded up and sanded back, and that will look really nice with a lot of kind of extruded kind of angles. The back section of this now will have off the front section, this will have tube that comes off maybe Johnny joints or something like that, and then rolls under with a nice spigot section coming up here with a trail gear retainer cap to go in this, which will hold that tire down, much like a trophy truck. I don't want to run the ratchet strap 3-tier section. That will roll into here and be very minimal on the height of that. So basically that tire is slid in on there, and then we have that big spindle which will hold that down. For the back of this, the entry of this and how heavy this tire is, I don't want to have to like lift it all the way above the tray and slide it out. It's very hard for someone. My idea here is I will pretty much back section of this, when we work out our angles and then we tie it into our profile, is this center section will be independent, and as it is all made up and everything like that, the floor will be in 3 tiers laid across. So between this section here, it will be cut into 3 tiers, 4mm base, and it will be provided on gas struts. And this section here with the tail lights, or not tail lights, with just a single light for your number plate, maybe some reverse lights in there and that. This section will be on a T-pull bar, sort of like your quick release fire extinguishers, and it will come up on gas struts and raise up, and then you can get your tire and pull it out. The outside of this will actually stay maintained in its spot. Outside of it, I don't know if we'll just do straight up rails like this, or we may do more sheet metal folding on that. It just depends, because it's a lot to form into this one tray, and I don't want to make the outside so crazy in design that if we do smash on this, it's hard to repair. So that's one thing to factor, is like the rear of this and the headboard probably not really going to get touched too much unless it's operator error or we bend the car upside down. As for the side rails, a very high chance of getting them dinged. Aluminium, cut it out, weld it in, good to go again. So that's where I'm sitting at with that. My next step that I'm going to do, that we're talking about, is I'll go through and make all this up, tack it all up, and then we'll shoot back once I've got this sort of ready to drop in and mitered, and we'll talk a little bit more where we're at with that. Righto, so fast forward a little bit, and we've gone through and started to pretty much form up our front slats. A bit of an intricate design going on here, as you can see, purely because of what we talked about before, building around the design that we've already got. We knew that was going to be pretty hard with the coil towers, and especially this tyre on the back. This tyre that we've got in here now, so that's a 35-inch trep, sort of biasing more to a 37 normal tyre. But as it sits at the moment, This design here is finalized, and I've actually stitched all this in pretty much through the top sections. One thing is that you'll probably notice here is this is going to get capped with 4mm plate, flat alloy, and have a bit of profile through it too once we get lasered out. These welds on top here will be cut down flush. So as I weld these, I actually wound the weld up to about 160 amps, which is a fair amount for 3mm alloy. But because I'm using the 2.4 rod, as I was welding it, I was actually feeding a lot in there. So it is not such a proud kind of weld as you can see. As your normal dabs, they get pretty proud. But this one here, they're quite flush already. And as I was doing it, you could see the penetration was massive. So I know that all these tops will be awesome once we sand them down. As for the outsides and stuff like that, just normal welding on that. So nothing too special. So as we move towards the back and the headboard, like I was talking about, we're going to go through and design up the headboard now, and it's going to be something that I probably won't show you too much of, just more near the end of it, once we actually go to form it up and design it all and everything like that, just because it's such an intricate design, and to show you on CAD and everything like that would drag out a fair amount. As for the back, I will have that a fair amount of videos of how we actually make this structure independent to everything else and give us that kind of boot space on the back to open up and pretty much give us our tyre instead of taking the tyre out. So that'd be pretty cool. As for all the slats and stuff, you'll probably notice a lot of it has been pretty strategic. Even though we're building a tray around everything else, we're still being strategic as we keep going. In this gap here in our wells, we've got tons of up travel we can have on this tray. That's going to be pretty awesome. So look, down the track, I'm sure we'll probably see 37s or 40s on this car. It's going to lead down to that path. So it'd be good to see it actually bolt on and work. The front guards on these are pre-runner flares. They permit up to about a 40-inch tyre. So we're already accounting for that in the rear, just in case we get to that point. So I'm pretty much going to call it there, guys. There's been a fair amount of work in this, an intricate design already. So this will probably tie off episode 1. Episode 2, we'll probably be looking at the rear section as we start to tie in a profile cut rear. And then we'll also look at this headboard assembly. We're probably going to look at 50 by 100mm box on the outside. We don't want it really wide on the back, but also we need to account for about 60 to 70% of the rear tyre coverage from the tray, or otherwise your guards start getting way too big. Also, we are trying to keep a bit of a design match with the front flares. Because they do extrude so far out, we want to tie them into the back and the rear and the front, sorry. And that will give it that kind of nice look that it looks even throughout the car. So anyway, thanks for watching, guys, and I'll catch you.